Bismillahirrahmanirrahim. Today we will cover lecture number 14 of Mechanics of Material 2. In this lecture, we will have a brief summarized form of Generalized Hooke's law, and we will develop some relationship among material constant E, G, K, and mu. For Generalized Hooke's law, if there is a cube on which triaxial stresses are being acted, epsilon, sigma x, sigma y, sigma z are being acted. As a result of sigma x, only this elongation will happen, and in this direction elongation is there, and sigma y elongation is only in this direction. Hence, due to sigma z, elongation is along z axis. But if you look at this, the effect of sigma x along x-axis will be elongation, and that can be represented by this equation epsilon x, that is positive is equal to sigma x by E, and it is according to Hooke's law in 1D, Hooke's law in one dimension in x-axis. So what will happen, what will be the effect of this sigma y along x-axis, only x-axis? So that will be epsilon x, x means along x-axis, double prime, it is due to second stress sigma y, that will be elongation is only y axis, so long x-axis there will be a contraction. That's why effect of Poisson ratio will be there, and we can say epsilon x double prime is equal to minus mu into sigma y over E, and the effect of sigma z along x-axis, again it will be contraction, and epsilon x triple prime is equal to minus mu into sigma z over E. So in these three equations we have just considered the effect along x-axis, and if we add these three up, we will get overall epsilon x, and that will be epsilon x equal to 1 over E, that is common among all these three equations, into sigma x, that is positive, minus mu sigma y minus mu sigma z. So this equation will be developed. Similarly, epsilon y is equal to 1 over E into sigma y minus mu into sigma x plus sigma z. Similarly, epsilon z is equal to 1 over E into epsilon z minus mu into sigma x plus sigma y. So these are three equations having the relationship between normal stress and normal strain. For shear strain, so shear strain will cause the shape to distort like this. Initially it was here, these normal stresses has changed the volume, this change of volume has been occurred, and this is called as dilatation. We will discuss later. So in shear, only change of shape is happened, and relationship will be gamma xy is equal to 1 over E 1 over G into tau xy, and for tau yz, gamma yz will be the change in shape or shear strain. So gamma yz is equal to 1 over G into tau yz. Similarly, gamma xz is equal to 1 over G into tau xz. So these three equations plus these three equations, these six equations will be called as generalized Hooke law. So then we will have a relation among material constant E, young modulus or elastic modulus, G, modulus of rigidity or shear modulus, K, bulk modulus, ratio of volumetric strain over stress over volumetric strain, mu, Poisson's ratio. Note, this relation holds good within elastic limit only. Dilatation, the change in volume per unit volume is called volumetric strain or the dilatation E. So volumetric strain or dilatation E is defined as the change in volume per unit volume is called as dilatation. Next, relationship involving E, K and mu. K is volumetric stress over volumetric strain, ratio of volumetric stress sigma mu over epsilon mu, and epsilon mu is the volumetric strain sum of epsilon x plus epsilon y plus epsilon z. And as we have discussed generalized Hooke's law, epsilon x is equal to sigma x over e minus mu into sigma y over e minus mu into sigma z over e. Epsilon y is equal to sigma y over e minus mu into sigma x over e minus mu sigma z over e, and epsilon z is equal to sigma z over e minus mu sigma x over e minus mu sigma y over e. For hydrostatic stress means all these stresses sigma x, sigma y, sigma z are same and equal. When these are equal, just put single one, and that is epsilon mu. So when you put here, it will become 2 double. So result is epsilon x is equal to sigma p over e into 1 minus 2 mu. Similarly, sigma x is equal to epsilon x is equal to epsilon y epsilon z, because these are same, that's why. So result of epsilon y and z will also same, that is equal to sigma v mu over e into 1 minus 2 mu. From equation 2, this equation, just epsilon v is equal to sigma x plus sigma y plus sigma z. When you put the value of this, so 1 plus 2 plus 3, so adding these, it will be thrice, because there are 3 epsilon common strains. So epsilon v is equal to 3 into sigma mu over e into 1 minus 2 mu. So having the ratio of, take sigma mu here and epsilon v in the denominator, and rest of the things take here. So these will be e into 3 over 3 into 1 minus 2 mu. So from here, this is also called as k, like that has been defined in question 1. So when you put k here, it will be k is equal to e over 3 into 1 minus 2 mu, and we can also write e is equal to 3k into 1 minus 2 mu, and this is equation 21. Relationship involving E, G and mu. State of pure shear, this can be transformed into an equivalent system of normal stresses using principal stress equations. So these can be transformed in this system, as we have covered in principal stresses. So applying equation of principal stress equation, that is sigma 1 2 is equal to 1 over 2 into sigma x plus sigma y plus minus square root of 1 over 2 into sigma x minus sigma y whole square plus tau x y square. Here sigma x is 0, that is not existing, sigma y is 0. So when you put 0 0 here and only tau x y exists, so result will be in square root tau x y square will be, so it will be due to square root, it will be plus and minus. So sigma 1 plus tau x y and sigma 2 is equal to minus x y. Similarly, principal strain equation, epsilon 1 2 will be equal to 1 over 2 into epsilon x plus epsilon 1 y plus minus square root of half of epsilon x minus epsilon y whole square plus half of gamma xy whole square. In figure A, epsilon x is 0 because there is no normal stress being acted. Epsilon y is 0 because no, only shape will change, that will cause the gamma xy according to Hooke's law. So epsilon 1 2 will be equal to epsilon equal to this, and end result will be epsilon 1 is equal to half gamma xy, epsilon 2 is equal to minus half gamma xy. And let's say this is equation P. From figure B, this epsilon 1 will be equal to, there are two normal stress being axes, sigma 1 and sigma 2. So along one axis epsilon 1 will be there, and value of this will be epsilon 1 is equal to sigma 1 over e minus mu into sigma 2 over e. So put the value of sigma 1, that is this one, tau xy, and sigma 2, that is minus tau xy. When you put here epsilon 1 is equal to tau xy over e minus mu into minus tau xy over e, minus minus plus, so it will overall result will be epsilon 1 is equal to tau xy over e into 1 plus mu, and this is equation Q. By P and Q, by P and Q, this and this, when you equate epsilon 1 here and put the value of this, so when you put the value of epsilon 1 from P in this Q equation, you will get 1 over 2 into gamma xy into tau xy over e into 1 plus mu. So take tau xy here and gamma xy in the denominator, and ratio of this according to Shear's modulus of rigidity or shear modulus, it will equal to G, and remaining thing is E will be E at the denominator, E over 2 into 1 plus mu. So relation will be, overall relation will be E is equal to 2G into 1 plus mu, and this is equation 22. So we have developed this equation and this relationship. Then relationship involving K, G and mu. What we will do, we will eliminate E in the previous two, from here and from here, eliminate E, and for that using equation 21 and 22. 21 is E is equal to 3K into 1 minus 2 mu, and 22 is E is equal to 2G into 1 plus mu. So equating these two, so this will be equal to this, and result will be 3K into 1 minus 2 mu is equal to 2G into 1 plus mu, and K will be equal to 2G into 1 plus mu over 3 into 1 minus 2 mu, and this is equation 23. So using previous two equations, we have developed this relation by eliminating E. And for relationship involving K, G and E, from equation, eliminate Poisson relation mu from equation 21 and 22. From 22, this was equation 22, E is equal to 2G into 1 plus mu. From here get the value of mu, and that will be E over 2G minus 1, E over 2G minus 1. Put in 21, this was 21, so E is equal to 3 into K into 1 minus 2 into, instead of B, put the value of this, that will be E over 2G minus 1. So E is equal to 3K into 1 minus, by multiplying 2 here, E over G plus 2 minus minus plus 2, so 2 and 1 3, so E is equal to 3K into 3 minus E over G, E is equal to minus, multiplying this, 9K minus 3K E over G, 9K, it will be positive here, E plus 3K E over G, having the LCM, EG plus 3K over G is equal to 9K, and E will be equal to G plus 3K over G is equal to 9K, and E will be equal to 9K G over G plus 3K, and this is equation 24. So we have done the relationship among K, G, E and mu. Thank you very much.